Now, if you see, the third is degree of reaction. Degree of reaction is pressure rise in the rotor blades. It is the ratio of pressure rise in the rotor blades to the pressure rise in the stage. Okay, the pressure rise in the compressor stage equal to the work input per stage. This is the degree of reaction formula. Okay, pressure rise in the compressor stage equal to work done or input per stage. And work input per stage we know, that is U2 in bracket VW2 minus VW1. Okay, and pressure rise in the rotor blades is at the expense of kinetic energy. At the rotor blades, it is moving and space is provided between this. Therefore, this the pressure rise due to change in relative velocity. That is the pressure rise in the rotor blades. So we can write degree of reaction is VR2 square minus VR1 square divided by 2. Okay, this is VR2 square minus VR1 square. Sorry, yeah. VR2 square minus VR1 square divided by 2, and this is U VW2 minus VW1. VW2 minus VW1. Okay, VW2 minus VW1. Okay, this is VR1. Okay, VR1 square minus VR2 square divided by 2. No, sorry. This is VR1 square minus VR, because VR2 is decreases. VR2 is decreases. Okay, that's why it is VR1 square minus VR2 square divided by 2U upon VW2 minus VW1. Now from the inlet velocity triangle. Now we see the inlet velocity triangle at inlet and outlet. See the tan theta and tan phi values. If you see, this is tan theta and tan phi values. Now, if you see the inlet velocity triangle, tan theta. Now, tan theta, this is the theta, tan theta. This is theta. Tan theta is equal to this triangle. If you consider this triangle, this is total U minus VW2. This is the total U. First is tan theta or tan phi. First we see tan theta. Okay. This is tan theta. Okay. This is theta. This is total U minus, this is VW1 minus UW1, U minus VW1 from this point to this point. This is U minus, from this point to this point is U minus VW1. The tan theta is equal to this theta. Tan theta is equal to U minus VW1 upon VF1. Now tan phi. If you see the tan phi, if you see this triangle, this is tan phi. Total is U minus VW2. So see, here is U minus VW2 is this one. From this point to this point is U minus VW2 upon the tan phi is U minus VW2 upon VF2. Okay, so tan theta is total is U minus VW1, that is this from this point to this point is U minus VW1, U minus VW from this point to this point is U minus VW1 upon VF1, that is tan phi, and from this is total is U minus VW2. So this is U minus VW2 upon VF2. So tan phi is U minus VW2 upon VF2. Okay. Let's see. Tan theta is equal to U minus VW1 upon VF1. U minus VW1 upon VF1 is equal to VF. So we can write U minus VW1 is equal to VF tan theta, or VW1 is equal to VW1 is equal to U minus VF tan theta. Okay. So for outer triangle, we can see tan phi is equal to U minus VW2 upon VF2, U minus VW2 upon VF. So VF1 is equal to VF2 is equal to VF. So we can write U minus VW2 is equal to VF tan phi. So therefore we can write VW2 is equal to this is come this side and this is this side. Therefore VW2 is equal to U minus VF tan phi. Now from equation number 1, equation number 2, because we have to find VW2 minus VW1. VW2 minus VW1. This is VW2 minus VW1. So we can write from equation number 2, from equation 1 and 2, we can write VW2 minus VW1 is equal to VW2 is this one, this value is put here, and this value is put here. We get VW2 minus VW1 is equal to VF tan theta minus tan phi. This is we get the value of VW2 minus VW1. VW2 minus VW1. Now we will find VR2 minus VR1. VR2 minus VR1. Again we are using Pythagoras theorem. By using Pythagoras theorem, we will find the VR1. First we will find the VR1. VR1, see this is VR1. VR1 square is equal to VF1 square. Plus this value from this U minus, this is VW1 minus, so total is U. So this from this point to this point is U minus VW1. From this point to this point is U minus VW1. So U minus VW1 square plus VF1 square is equal to VR1 square. See this triangle. This is the triangle. Okay. So VR1 square equal to VF1 square, and this distance is U minus VW1. This distance is U minus VW1. Okay. So this is VR1 square equal to VF1 square plus U minus VW1 whole square. Now what is U minus VW1? This is U minus VW1. That is Vf tan theta. That is Vf tan theta. Put the values of U minus VW1 is equal to Vf square tan theta square. So we will get Vf square tan square phi theta tan square theta. That is equation number 3. Now VR2 square. Now we see the again VR2 square. See the this is VR2 square. This is VR2 square equal to this distance. This distance is U minus VW2. Total is U minus VW2. This is U minus VW2 square whole square plus VF2 square is equal to VR2 square. Okay, so this is VR2 square equal to VF square plus U minus VW2 whole square, outer triangle. We get VF2 square. What is U2 minus VW2? From this equation, U2 minus VW2, we will get Vf tan phi. Now put the value of U2 minus VW2 is Vf tan phi. Now this squaring this is square. Okay. Now VR2 square minus what we want, VR1 square minus VR2 square. VR1 square minus VR2 square. VR1 square minus, that is by mistake VR2. That is VR1 square minus VR2. So VR1 square minus VR2 square is equal to this. Put these values here. Put this value minus VR2 here. This VR2. Put the value here. Okay. And Vf1 square is cancelled. By solving this, we will get Vf square is equal to tan square theta minus tan square phi. Now put the values of VR1 minus VR2 square. VR1 minus VR2 square here. VW2 minus VW1, this value. Put this value in this equation and this value in these equations. Okay, we will get RD is equal to Vf square tan square theta minus tan square phi upon 2U. And what is the value of VW2 minus VW1? This one. Vf tan theta minus tan phi. And this is 1 by 2 Vf by U. This is a minus b square, a plus b, a minus b. So that's why tan theta minus tan phi is cancelled. Now here is 1 upon u Vf by u tan theta plus tan phi. Now generally degree of reaction is 50% in axial flow air compressor. Therefore we can write 50% means it is 1 by 2. Here is 1 by 2 Vf by u is equal to tan theta plus tan phi. Therefore, we can write U by Vf is equal to tan theta plus tan phi. This is the most important equation. This is the most important. In every problem, without this equation, you cannot solve. So, you must remember this equation U by Vf is equal to tan theta plus tan phi. This is the most important equations. Without knowing this equation, you cannot solve the axial flow problems. Okay. So, you can remember this equation U by Vf is tan theta plus tan phi. Now, if you see. This is the equation number 5. Now, tan theta plus U by Vf is equal to tan theta plus tan phi. Now, we see alpha and theta. Now, in the diagram, we see alpha and theta. Tan alpha is equal to W1 upon Vf1. Tan phi is equal to U minus Vw2. This is the distance. U minus Vw2 upon Vf. First, again, alpha and phi. See, alpha and phi. This is phi angle, this is alpha angle. Okay. Tan alpha is equal to Vw1 upon Vf1. Tan phi is equal to this distance U minus Vw2 upon Vf. See, alpha and phi. Okay. So that is here is take alpha and theta. Okay, no issue. We can take alpha and theta also. Tan alpha and theta. This is theta. Tan alpha is equal to Vw1 upon Vf1. Okay, and tan phi is equal to this distance U minus Vw1. U minus Vw1, this distance U minus Vw1 upon Vf1. Okay, so what will you get? Tan alpha, tan theta. Okay, this is Vw1 upon Vf, U minus Vw1 upon Vf. So we get tan alpha plus tan theta is equal to Vw1 minus Vf. Vw1 minus Vf is cancelled. Therefore, we can get again this equation U by Vf is equal to tan alpha plus tan theta. This is equation number 6. Now beta and phi. Now we see beta and phi. This is beta.